All right, guys, so we're going over the review sheet today. Your test is tomorrow. So, yes, I think you know where they're at. So, let's look at this first one. We'll look at these first two here. So the first one, 3y squared minus 4y is equal to 8 minus 6y. Since we do have a y squared, we do need this equal to 0. So the first thing we can do is, one is going to be to add 6y as well as subtract 8 from both sides, which will tell us that we have 3y squared. Negative 4y plus 6y is going to be plus 2y. Here we don't have any like terms with 8, so we'll get negative 8. So we move everything over to the same side. We get 3y squared plus 2y minus 8 is equal to 0. Now at this point here, we do need to solve. In one of our methods, we can use the quadratic formula. Our x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Because this is one method that we can use for this here. We could do completing the square, moving the 8 over, turning it into a set of parentheses squared and going from there. We could factor it or we could graph it. Yep, two sets of parentheses. So we're going to go about factoring. Since the 8 is negative, our signs are going to be opposite. One's going to be positive, one's going to be negative. Our factors of y squared are y and y, and we'll have 1 and 3. So most likely we'll have a middle term that is positive, so I'm going to put the 3 over with the negative. It's just a guess at this point, because again, we can check it here in a minute. And the only factors of 3 are 1 and 3. Now factors of 8 are 1 and 8 or 2 and 4. If I had to guess, I'm going to say 2 and 4. Because I know 4 times 3 is going to be a little bit big, so we can try this here. Now, we can check it just to make sure. Y times negative 4 is going to be negative 4y. 2 times 3y is going to be plus 6y, which does give us a positive 2y. Now that we have two things multiplied together to equal 0, one of them must be 0. For the first one here, we would subtract 2 from both sides, telling us y is negative 2. For the other one here, the first thing we'll do is add 4 to both sides, telling us 3y is equal to 4. And last but not least, we would divide both sides by 3, telling us y is 4/3. So y is negative 2 and y is 4/3. Any other questions on this one here? I also want to look at number 2. Now, number 2 is a little bit different than the first one because we do have a set of parentheses squared, and there is no variable outside of those parentheses. If the variable is only contained inside the parentheses, or it specifically tells you in the instructions to use the square root method, I'd use the square root method. Because what we can do is get those parentheses by themselves by adding 1 to both sides. Because once we do that, we're saying that the quantity 2x plus 3 squared is equal to 7. And once we get that set of parentheses that's being squared by itself, we can take the square root of both sides. And here the square root and square will cancel, telling us that 2x plus 3 is equal to plus or minus the square root of 7. Now we just need to get x by itself. Now the first thing we can do in getting x by itself is to subtract 3 from both sides, which on the left-hand side will give us 2x. Now, Standard notation states that we put the -3, or when we're subtracting the 3, in front of the plus or minus, just so that we know that the plus or minus is mainly attached to the square root of 7. Now, is the square root of 7 a rational number? No, it's a non-repeating, non-terminating decimal, so we'll leave it as the square root of 7. That also means that I'm not going to get a nice answer. It's not going to be a nice number of 4 or just a single number or a fraction. So we'll leave it as plus or minus. Now we do have one last thing in that we need to divide both sides by 2. Because we will get x by itself is equal to -3 plus or minus the square root of 7 over 2. And you can leave it as this here. You don't have to rewrite it back out as -3/2 plus the square root of 7 over 2, and x is equal to -3/2 minus the square root of 7 over 2. We don't have to break it apart or simplify it all the way down to there. I will take it as -3 plus or minus the square root of 7 all over 2. I will take it as the 1. Okay? Questions on this here? I'm going to leave 3 for y'all. If you do have questions, please come back and ask. I'm going to leave a few of these for y'all to do just in case you didn't have time last night to work on them. So you do have some more to work on and have some more practice with these here. Any questions on number 4? Okay, that's fine. If you do end up working it out later, the first main thing I would suggest is getting rid of those fractions. Multiply the whole thing by a number that would remove them and go from there. After you do that, it's going to make it easy to work. And kind of my hint for this is 15. Because 1/5 of 15 is 3. 2/3 of 15 is 10. Because 15 divided by 3 is 5, times 2 is 10. And 7/15 times 15 would be 7. You have all whole numbers, and then it's going to be easy to go from there. All right, let's look at this one here. Solve by completing the square. We didn't do too many like this in class. I think there might have been 1 or 2 like it on the homework. But the main thing with this here is that when we do completing the square, a has to be 1. The number in front of x squared has to be 1. Which means here we have to divide everything by whatever that a value is to start with. 2x squared divided by 2 is going to be x squared. Minus 3/2 x minus 5/2 is equal to 0. Now, it might be very tempting to turn these into decimals because up to this point, using decimals or working with decimals was easier than fractions. But with completing the square, it's going to be a lot easier to work with fractions than it is going to be decimals. Now, the next thing we'll need to do is get the x squared and x terms by themselves. So we're going to have x squared minus 3/2 x plus blank is equal to 5/2 plus blank. Because what we're wanting to do is rewrite this quadratic as a set of parentheses squared, which involves us finding whatever value of c, the constant term, that will turn it into a perfect square trinomial. Now for us here, that term, that number, is b over 2 squared. And for us here, the value of b is our -3/2. Now, the first thing we can do is the -3/2 divided by 2. And we can plug that in a calculator. We can say fraction on the top, -3/2 over 2 is -3/4. And then we can also square it, and if we square it, -3 squared is 9, 4 squared is 16. And if you're wondering, yes, c is always going to be positive. For these perfect square trinomials, c will always be a positive number. Because whenever we square a number, multiply it by itself, it's going to be positive. Now when we factor this down, it's perfect square trinomial, we're going to have x by itself. And the reason we do have x by itself, there's not a number in front of it, is because of our first main step, dividing by a, so that it will be by itself. What goes inside it is whatever we have inside the parentheses before we square it. Since it's negative 3/4, this is going to be minus 3/4. This is also why I don't just plug into the calculator parentheses negative 3/2 divided by 2, close parentheses, squared. Because if I simplify it before I square it, I have what's going to be going in there. It's a nice and easy way to factor it. Now the other side, we need to do 5/2 plus 9/16 is 49/16. This problem is being very nice. Any questions on this so far? Now it might be odd I tell you that this problem is being very nice, because our next main step is 2, square root both sides. Here the square root and square will cancel, leaving us with x minus 3/4 is equal to plus or minus. And again, when we take the square root of a fraction, we can take the square root of the numerator and square root of the denominator separately. And if we look at the numerator of this fraction, what is the square root of 49? 7. Square root of 16 is? That's why I say it was nice. Because we aren't left with a radical. They both reduce. They were both perfect squares, which is, for this problem, quite nice. Then the last thing we need to do is add 3/4 to both sides, which tells us x is equal to 3/4 plus or minus 7/4. If a problem like this shows up on the test and you get an answer of x equals 3/4 plus or minus 7/4, I will take points off if you leave it here. Can I add 3/4 and 7/4 together and get a single number? Yeah. And we can also subtract them. You're going to have to add and subtract them. Because 3/4 plus 7/4 is 10/4. We can say 5/2 or 2.5 or 2.5. Any of these here. Really, if you did 3/4 plus 10/4 and the calculator hit enter, it'll give you 5/2, or you can turn it into a decimal. Okay? 3/4 minus 7/4. 3 minus 7 is negative 4, which is negative 1. So our solutions are negative 1 or one of those three. 5/2, 2.5, 2.5. Any of those will work. You just need to pick which one you want to use. Now, if it had been left as a square root of 7/4, then that would have been fine. 3/4 plus or minus the square root of 7/4. That is the final answer. We can't add or subtract those. The only way we could do it is merge them into one, but that's still the same answer. And the main reason I'm saying I'd count points off on this, because if we can reduce it, reduce it. If we can reduce it, we can reduce it. If we have the actual number answers we want to. Questions on this here? So this is, we've already covered the square root method. If we need to come back to it, we can. Absolute values. Absolute values equations. Whenever we solve these, the first thing you need to do is make sure to get the absolute values by themselves. 7 or 8, which one do y'all want to look at? Between these two here. 8. First thing we're going to need to do is get the absolute value bars by themselves. So the first thing I'm going to do is subtract 4 from both sides. negative 5/4 minus 4. Is negative 21/4. Now at this point here, the absolute value bars are not by themselves, so there's one of two things we can do. We can either divide both sides by negative 7/4, or we can multiply both sides by negative 4/7. I'm just flipping the fraction. We can do that on both sides. Because over here, 4/4 simplifies. 7/7 simplifies, and the negative and negative make a positive. It simplifies out. It would be the exact same as if we divided. Which leaves over here the absolute value of 3x minus 8 is equal to, well, here negative and negative make a positive. The 4 and 4 will cancel, leaving us with 21/7. 21 divided by 7 is 3. Any questions on how we got the absolute value bars by themselves? Now we know the absolute value of any number is always positive, yes? But what's inside the absolute value could be 3x minus 8 could be 3, or 3x minus 8 could be negative 3. Because if what's inside the parentheses was positive or negative 3, when it comes outside of the parentheses, or not parentheses, absolute values, it'll be positive. So we have to solve both cases. At this point here, we would add 8 to both sides, telling us that 3x is equal to 11. Divide both sides by 3, telling x is equal to 11/3. The other side, we would do the same thing. We would add 8 first, telling us that 3x is equal to 5. Then we would divide by 3, telling us x is equal to 5/3. Questions on this here? Now again, if you feel like the numbers are really weird and you don't trust them, plug them back into the original problem. Plug them back in and see if you get a true statement. So we got negative 5/4. Snag this from you for a second. I'll get it right back. I'll show you this here because we can go second quit. So here, alpha y equals enter. Negative 7/4. Math over the number. The first one there, ABS, is absolute value. 3 times, well, let's do it this way. Alpha y equals enter 11/3, which is one of our answers, minus 8 plus 4. So this is the one side of the problem, and it says it should be negative 5/4, yes? So if I hit enter, so that is the correct answer. We can check it. I think the other one was, what was it, negative 5/3? 5/3, yeah. Delete. Still gives us the negative 5/4, so it is the correct answer. But that's it there. Inequalities. We can look at number 9 for this one here. Now again, with inequalities, the main thing is that we need to get the absolute value bars by themselves. So the first thing we can do is subtract 6 from both sides, which tells us that we have negative absolute value of 5 minus x is greater than or equal to negative 2. But again, we need the absolute value bars by themselves. Since there's a negative out in front of it, we're going to have to multiply or divide by -1. Doesn't matter which, they will do the exact same thing, which tells us that the absolute value of 5 minus x is less than or equal to 2. So when it's less than, with absolute value, it's an and statement. When it's greater than with absolute values, it's an or statement. Less than or greater. So since this is a less than statement, we're going to have 2, and it is going to be and. Because one case we're saying is that 5 minus x is less than or equal to 2. That is one of our statements. Now, just like with the previous one, we are going to change one of the sides from positive to negative. So we're saying -2. But when we do this, we have to change our symbol from less than to greater than. It's still an and statement, but we have to flip the 1. Because really what we're saying with this here is that all the values coming out of this are going to be between 2 and -2. They're between 2 and -2. That's where they're all going to lie. And we need to see how x is going to come into play with that. Now, the first thing we can do here is subtract 5 from both sides, which will tell us -x is less than or equal to -3. Divide or multiply by -1 tells us x is greater than or equal to 3. We can do the exact same thing to the other side. We can subtract 5 from both sides, which tells us -x is greater than or equal to -7. And again, divide both sides by -1 tells us x is less than or equal to 7. And again, this is an and statement, so our only solutions are what's in common. If we think of it as a number line, our two key points are 3 and 7. X is greater than or equal to 3. Since it's an and statement, I'm going to draw it above it. So it'd be equal to this and going to the right. X is less than or equal to 7. So at 7, it'd be filled in, and we would shade to the left. And we only bring down what's in common in both. Since both spots are filled in, we're going to fill both spots in and shade in the middle. So this here is our solution. This here is the graph of it. And interval notation is going to be with our parentheses and brackets. Now, since 3 and 7 are both included, we'd have two brackets, and it'd be 3, 7. Smallest number is always on the right, or sorry, smallest number is always on the left. Bigger number is always on the right, going left or right. And really, the number of times that we shade is going to be the number of sets of parentheses that we have. If you think back to the homework for 1-7, when they went off in two directions, we shaded 2 spots. We had 2 sets of parentheses. Now, for the test, especially if we have 2, I will take either one of these symbols, conjoining the 2. So you can write or the union. If you want to put both, one over the other, like I have it here. I will take either one. Any other questions on number 9? Yes? Or here? So when we multiply or divide by negative, we're taking the opposite of it. Because here, I think the best way to show this is saying -x is less than or equal to -3, yes? So, okay, let's just say, actually I think I know the best way to do this. Let's say I don't switch it. X is less than or equal to -3, yes? So, -5, I'm just would make this statement true, yes? let's say 5 minus negative 5 is less than or equal to 2, yes? So if this works, this would still be true. Negative and negative makes a plus 5 is 10. This is no longer true. And that's kind of the reason. When we take the opposite of it, the negative is the opposite. So I changed this value from the negative side of the x-axis, or kind of our one line, to the positive. And on the other side, we went from, or one side to the other, yes? So that inequality has to change to adjust for that sign change, that flipping it from one side to the other. Does that make more sense? And again, that's not something we really cover, especially when we talk about inequalities the first time. It's like, this is the rule, this is how it works, and we're going to go from there. And part of it's just that's how we've always done it, but also trying to have a mental conception of flipping sides of a number line and that changing with it is a little hard as a middle schooler, trying to get a conceptual view of how that works. But does that make more sense to y'all now, why we do that? Okay. I'm not going to worry too much about 10. I think y'all can get number 10. It's not a quadratic. That's why I added the plus 12x squared. The x squareds will cancel out. It's just going to be linear. Any other questions with these linear or absolute value inequalities? Or do we feel comfortable with these here? You know what? Because we can look at, you want to look at number 10 or number 11? Ten or 11. 11. If we look at this here, the big thing with this is the three fractions that we have, yes? Now, the numbers that we have in the denominator are 3, 6, and 2. If we can multiply it all by a set number to make them go away, what is the first number that 6, 3, and 2 are all divisible by? 6. So what I'm going to do is multiply every term in this by 6. Because if we do 6 times 1/3, we get 2. 6 divided by 3 is 2. Here, the 6 and 6 would cancel. 6 times 1/2 is 3x, and 1 times 6 is 6. So like the problem I said earlier with using the 15, similar process. Now at this point here, we can distribute. 2 times x is 2x. 2 times 4 is going to be plus 8. Negative 5 times x is negative 5x. Negative 5 times negative 3 is plus 15. 2x minus 5x is going to be negative 3x. 8 plus 15 is going to be plus 23. Is greater than or equal to 3x plus 6. Now at this point here, we do need to get x by itself. So I'm going to add 3x to both sides, because these will cancel, leaving 23 by itself. Is greater than or equal to 3x plus 3x is 6x plus 6. Then we can subtract 6 from both sides. 23 minus 6 is 17. Last but not least, we can divide both sides by 6, telling us that, put it up just a little bit, 17 over 6 is greater than or equal to x, or we can say x is less than or equal to 17 over 6. If we were asked to graph this, I just make a number line and put 17 over 6 in about the dead center. I'm not making you draw these number lines with respect to 0. Just make sure, especially if there's more than one number on the number line, that they are set up in the correct order. Smaller number on the left, bigger number on the right. Now at 17/6, it is filled in because it is equal to, and since x is smaller than it, we would shade to the left. Now in interval notation, we're talking about negative infinity, comma, 17/6, bracket. Now you don't have to give all three of these on every single one, just make sure to read the instructions and see what it asks for. Because if it asks you to solve and write it in interval notation, we're looking at these two here. If it tells you to solve and graph, we're only looking at this one and this one. If you're not sure and you want to put all three, go on and put all three. Any other questions on this here? Solving radical equations. Whenever we solve radical equations, the first thing we want to do is get the radical by itself. So here the first thing I would do is add 3 to both sides, which will tell us 2 square root of 3x plus 4 is equal to 8. Then the next thing we can do is divide both sides by 2, which tells us the square root of 3x plus 4 is equal to 4. Since we got the radical by itself, we can square both sides, which tells us here the radical and the square will cancel, leaving us with 3x plus 4 is equal to, well, 4 squared is 16. Now on these here, we don't need the plus or minus. We only need the plus or minus when we square root both sides. Now at this point here, we just need to get x by itself, so we can subtract 4 from both sides, telling us that 3x is equal to 12. When we divide by 3, x is equal to 4. All right, guys, so we'll do 2 more problems, one of each of the word problems, and then that's going to cover everything on the test. Okay, let's look at 16. One pump can drain a pond in 22 hours. Working with a second pump, the 2 pumps can drain the pond in 10 hours. How fast can the second pump drain the pond? So we're talking about this work. We want to look at it as the whole thing per the number of times or however long they're working. So one pump can drain it in 22 hours. So this one pump can do it in 1 over 22. 1/22 of an hour. Or sorry, in an hour, 1/22 of the work is done out of the whole thing. Now if they work together, it can drain it in 10 hours. So it's getting 1/10 of it done in an hour. Makes sense so far, yes? So what do we know about pump 2? Do we know how fast it can drain it? No. So we're going to call the second pump what? 1 over x. So total, pump 1, 1 over 22, added to the speed of pump 2 will give us the total of 1/10. Now we do need to find the least common multiple for these here. But luckily, since the only variable we have is what? X, yes? So I could just multiply everything by x, by 10, and by 22. The only thing that this is going to do is make the numbers look bigger than they needed to be, but it'll still get to the same answer. Doing multiple of variables is not as good because it'll add extraneous solutions. For the 22, the 22 and 22 will cancel. On the other side, the 10 and 10 will cancel. And what this will leave us with is 10x plus, well, 22 times 10 is 220 is equal to 22x. Questions on this here? Now we just need to get x by itself. So I can subtract 10x from both sides, which tells us that 220 is equal to 12x. And last but not least, we would divide both sides by 12. So x is equal to 220 divided by 12 is 18.3 repeated, or 18 1/3. Either one of these here. Questions on this here? And whenever we're talking about work problems or problems that involve work or doing a job of some kind of stuff like this here, the sum, the total of times it takes for both of them to work will always be less than both of their times. Okay? Or vice versa. The total time should be less than both of what they can do individually. Any other questions on this here? Now again, on the word problems, do make sure to fully answer them. Some of them have two parts. Kind of the second part for this here, which one would you prefer to use if you were draining the pool by itself? Pump number 2, because it does take less time. Okay. Last one we'll look at is 17 or 18. Which one do y'all want to look at? Stopping distance of the car or the firework? The car. So they are the similar type problem. The problem number 18 technically has a flaw in it because there aren't going to be two times technically where the firework's at the same height, because hopefully it blows up at the apex of it and not come back down. But I would ignore that part. So here, the stopping distance d in feet of a car on a certain road is given by this equation, where v is the speed of the car in miles per hour before the brakes were applied. If the stopping distance of the car is 390 feet, how fast was the car traveling before the brakes were applied? So we're saying 390 is equal to 0.048 v squared plus 2.2 v. Now we are going to need this equal to 0. So we subtract 390 from both sides. Counting to 0 is equal to 0.048 v squared plus 2.2 v minus 390. So we inputted the data and went from there. Now at this point here, there's a good chance we're not going to get nice numbers. And I would stray away from using completing the square on this because, again, with completing the square, the number in front of x squared, or in this case v squared, would need to be 1, which would involve us dividing everything by 0.048. 48 thousandths. So I wouldn't want to do that. So I would use the quadratic formula. Now, also with the quadratic formula, 0.048 is not a nice number. However, if I multiply this by 10, we get 0.48. If I multiply it by 100, we get 4.8. And if I multiply it by 1,000, I move that decimal 3 over, we get 48v squared. That's a nicer number to work with, yes? Plus, well, I moved it 1, 2, 3 times. So here I've got to move 1, 2, 3 times. And yes, I only had one decimal that I can move it, but the other two become zeros. And over here, we're going to move this decimal 1, 2, 3 spots. So it becomes 390,000. Now again, these are some big numbers, but again, quadratic formula, calculator is going to do most of the work for us. So negative b, so this would be negative 2,200 plus or minus the square root of b squared minus 4ac all over 2 times a. Well, 2 times 48 is going to be 96. In the calculator, 2,200 squared minus 4 times 48 times negative, what is it? 390, 1, 2, 3. Enter. 7972. 7972. 4 zeros. What are the odds that that's going to be a nice number? Not very likely, yes. So, and again, it said to round to the nearest decimal point, yes? We're approximating this thing. And especially with the word problems, there's one like it on the test. At this point, plug it into the calculator. Fraction, negative 2,200 plus second square root, 797, 1, 2, 3, 4, over 96, yes? And I think it said to the nearest mile per hour. Got 70.08 or 70.09. But if I remember the instructions correctly, okay, it didn't say. On the test it will say, so if it says the nearest mile per hour, this would just be 70. Does that make sense there? Really, at this step here, you could have typed it in as you have it there with the plus, not the plus and minus, can't do both. Just do the plus and get your answer and it'll give you 70. We can also come back here. Okay. Go away, come back. I can select this again and use the cursor and come over in front of the square root and change it from plus to minus and enter again. Negative 115.9. Are our two answers. Are both of these legitimate answers? No, which one doesn't work? Negative 115.9. We can't have negative miles per hour. That's also why it says an answer. We get one. With the stopping speed. For some of them, like the firework, we can't have two answers because there's 2 spots it'll hit that. So again, sometimes it'll have 2, sometimes it'll have 1. But that is it for this here. Questions on any of this here? So guys, your test is tomorrow. Make sure to go over this and be ready because you will have 45 minutes to complete the test. Okay, so you will have a class period. Actually, it'll be 50 minutes. I know it'll be 45 minutes in here. I will give you time into breakfast to finish it up. Okay.